Out there, among the stars, lies a treasure trove of resources so vast it could redefine the future of humanity. Metals like platinum, gold, and rare earth elements are scattered across asteroids, moons, and planets, just waiting to be discovered. But here's the catch: extracting these resources is no easy feat. The challenges of space, its vast distances, harsh environments, and zero gravity make traditional mining methods impossible. That's where artificial intelligence and robotics come in. These cutting-edge technologies are the key to unlocking the potential of interstellar mining, transforming science fiction into reality. In this video, we'll explore how AI and robotics are revolutionizing space mining, from autonomous rovers that navigate alien terrains to intelligent systems that process resources on the go. We'll also delve into how these advancements could solve Earth's resource limitations and pave the way for a new era of exploration and innovation. Stick around, because what you're about to discover might just change the way you think about the future of humanity. Space mining might seem like a modern idea, but its roots stretch back decades, born from the pages of science fiction. Authors like Isaac Asimov and Arthur C. Clarke envisioned a future where humans mined the stars, tapping into the seemingly infinite resources of the cosmos. For years, these ideas remained firmly in the realm of imagination. But in the late 20th century, the conversation began to shift. Scientists and engineers started seriously considering the possibility of extracting resources from asteroids, moons, and even other planets. Early missions like NASA's Near-Earth Asteroid Rendezvous in the 1990s marked the first steps toward turning these theories into reality. These missions revealed the potential of space mining, but also highlighted the immense challenges. Traditional methods reliant on human labor and heavy machinery were simply not feasible in the unforgiving environment of space. Enter artificial intelligence and robotics. These technologies have fundamentally changed the game, offering solutions to problems once thought insurmountable. AI can analyze vast amounts of data to identify resource-rich asteroids, while robotics enable precise, autonomous operations in zero gravity. Together, they're paving the way for a new era of interstellar mining, one that's efficient, sustainable, and scalable. But how exactly are these innovations reshaping the industry? Let's dive deeper into the specific roles AI and robotics are playing in this groundbreaking field. Artificial intelligence is the brain behind the future of interstellar mining, a game-changer that's redefining how we approach resource extraction in space. One of its most critical roles is processing and interpreting the overwhelming amounts of data collected from distant asteroids, moons, and planets. Imagine trying to sift through terabytes of information, everything from geological maps to spectrometer readings, without the help of AI. It would be like finding a needle in a cosmic haystack, but with advanced algorithms, AI can analyze this data at lightning speed, pinpointing the most promising locations for mining. These systems can identify specific elements, map out terrain, and even predict the stability of a mining site, all without human intervention. For example, NASA's Perseverance rover uses AI-driven software to autonomously navigate the Martian surface, selecting rocks for analysis based on their scientific value. But AI's capabilities don't stop there. Machine learning plays a crucial role in predictive maintenance, forecasting potential equipment failures before they happen. This not only reduces downtime, but also ensures the safety and success of missions that are light years away from Earth. Autonomous systems like these are already proving their worth in space exploration, paving the way for more complex mining operations. But AI doesn't work alone. It's part of a dynamic duo. Robotics, with their precision and adaptability, bring these intelligent systems to life, creating a synergy that's essential for the challenges of interstellar mining. Together, they're transforming what was once a distant dream into a tangible reality. The collaboration between artificial intelligence and robotics is nothing short of revolutionary, especially when it comes to the unique demands of interstellar mining. Picture this: a robotic rover equipped with AI-powered sensors, navigating a rugged asteroid surface, avoiding obstacles and identifying the best spots to drill. These systems are designed to operate in environments where human presence is impossible: extreme temperatures, zero gravity, and unpredictable terrain. Take NASA Mars rovers as a prototype. While they're not mining vehicles, their autonomous navigation and decision-making capabilities showcase the potential of AI-driven robotics. Now, imagine scaling that technology for mining purposes. Companies like Planetary Resources and Deep Space Industries are already developing robotic systems specifically for extracting resources from asteroids. These robots can perform complex tasks, from drilling and excavating to processing materials on site, all with minimal human intervention. AI plays a crucial role in enhancing these operations. For instance, machine learning algorithms enable robots to adapt to unexpected challenges, like a sudden shift in terrain or a malfunctioning tool. This adaptability not only increases efficiency but also reduces the risk of mission failure, which is critical when you're operating millions of miles from Earth. What's more, AI helps optimize resource allocation, ensuring that every movement and action is calculated for maximum precision. This synergy between intelligence and machinery is transforming space mining from a high-risk endeavor into a viable, cost-effective industry. But the true game-changer lies in the level of autonomy these systems can achieve. As we move into the next phase of space exploration, the ability for machines to operate independently, making real-time decisions without human input, will be the cornerstone of success in interstellar mining. Let's explore what that future might look like. Autonomous systems are the backbone of interstellar mining, enabling robots to operate with minimal human oversight in environments where every second counts. But what exactly does autonomy mean in this context? These systems are designed to make decisions on their own, using AI to analyze data, solve problems, and carry out tasks without waiting for instructions from Earth. This level of independence is crucial when you're dealing with the vast distances and harsh conditions of space. For example, a mining robot on an asteroid might detect a sudden shift in terrain or a mechanical issue. Instead of sending a signal back to Earth, which could take hours or even days to receive a response, it can assess the situation and take corrective action immediately. This reduces communication delays, a major bottleneck in space missions, and speeds up operations significantly. Autonomy also boosts mission reliability. By equipping robots with advanced decision-making capabilities, we minimize the risk of errors that could jeopardize the entire mission. Companies like Off-World and Honeybee Robotics are pioneering autonomous mining technologies, developing robots that can drill, collect, and process materials with unprecedented precision. Off-World's robots, for instance, are designed to operate on the Moon, using AI to navigate and adapt to the lunar surface. These advancements are pushing the boundaries of what's possible, but implementing autonomous systems in space isn't without its challenges. From ensuring robust AI algorithms that can handle unexpected scenarios to designing hardware that withstands the rigors of space, there's still a lot to overcome. As we delve deeper into these challenges, it's clear that autonomy isn't just a luxury, it's a necessity for the future of interstellar mining. While the promise of interstellar mining is immense, the challenges it presents are equally daunting. One of the biggest hurdles is the sheer unpredictability of space itself. Zero gravity, for instance, complicates even the most basic tasks. On Earth, mining equipment relies on gravity to function. Drills bore into the ground and conveyor belts transport materials with ease. In space, however, these mechanisms become unreliable. Tools and debris can float away, and traditional mining techniques simply don't translate to a weightless environment. Then there's the issue of extreme temperatures. Asteroids and planets can swing from scorching heat to freezing cold in a matter of hours, posing a serious risk to both equipment and operations. High radiation levels add another layer of complexity, potentially damaging electronics and making long-term missions even more perilous. And let's not forget the logistical nightmare of transporting mined resources back to Earth. The cost and energy required to launch payloads from space are astronomical, pun intended. Equipment failure is another significant concern. A malfunctioning drill or a broken sensor could derail an entire mission, especially when repairs require human intervention, something that's not feasible in deep space. But here's where AI and robotics step in as game changers. Advanced AI systems can predict and prevent equipment failures before they happen, while robotic arms and tools are being designed to operate seamlessly in zero gravity. Companies are also developing innovative ways to process materials in space, reducing the need to transport raw resources back to Earth. For example, 3D printing technologies are being explored to turn mined materials into usable components on site. These solutions are not just addressing the challenges of interstellar mining, they're reshaping our approach to space exploration altogether. As we look ahead, it's clear that the fusion of AI and robotics will be the driving force behind overcoming these obstacles, setting the stage for a new era of innovation and discovery. So, how are we tackling these monumental challenges? The answer lies in the incredible advancements being made in AI and robotics, technologies that are reshaping the very foundation of interstellar mining. One of the most groundbreaking innovations is the development of self-repairing robotic systems. These robots are equipped with advanced sensors and AI algorithms that allow them to detect and fix minor issues on their own, reducing the need for human intervention and minimizing mission downtime. Think of it like a self-healing organism. When a component malfunctions, the system can autonomously replace or repair it, ensuring operations continue smoothly. Another game changer is AI-driven resource mapping. By combining satellite imagery, geological data, and machine learning, these systems can create highly detailed maps of asteroids and planets, identifying the most resource-rich areas with pinpoint accuracy. This not only saves time but also maximizes efficiency, allowing mining operations to focus on the most valuable targets. Adaptive mining techniques are also revolutionizing the industry. Unlike traditional methods that rely on static equipment, these systems can adjust their approach based on real-time data. For instance, if a robot encounters a particularly hard rock, it can switch to a different drilling method without skipping a beat. And let's not forget the role of 3D printing. This technology is enabling the creation of tools and structures directly on site using mined materials. Imagine a rover that can print replacement parts or even construct a habitat using resources extracted from the asteroid it's mining. Recent breakthroughs, like the European Space Agency's project to 3D print lunar bases, are already proving the potential of this approach. These innovations aren't just solving technical challenges, they're opening the door to a future where interstellar mining is not only feasible but also economically and environmentally sustainable. But what does that future look like? Stick around, because the ripple effects of these technologies could transform more than just space exploration. The economic potential of AI-driven interstellar mining is nothing short of transformative, offering a gateway to resources that could reshape industries back on Earth. Take platinum, for example, a metal that's essential for electronics, medical devices, and clean energy technologies like fuel cells. On Earth, platinum is rare and expensive to extract, but asteroids potentially hold vast quantities of it. Similarly, helium-3, a rare isotope found in lunar soil, could revolutionize nuclear fusion, providing a virtually limitless and clean energy source. These resources aren't just valuable, they're game changers for economies and industries worldwide. But how does AI make this feasible? By automating the entire mining process from exploration to extraction, these technologies drastically reduce costs. Autonomous systems eliminate the need for expensive human labor and the logistical challenges of supporting life in space. Robots don't need food, water, or oxygen, and they can work around the clock without fatigue. This efficiency isn't just about saving money, it's about making interstellar mining economically viable in the first place. Beyond the immediate benefits, this industry has the potential to create entirely new sectors, from space-based manufacturing to asteroid prospecting. It's not just about mining, it's about building a new economy that extends beyond our planet. And with it comes the potential for job creation, not just in space but also here on Earth, as industries develop to support this burgeoning field. But as with any major technological shift, there are trade-offs. While the economic benefits are clear, we also need to consider the environmental implications of mining in space. How do we ensure that our quest for resources doesn't come at the cost of the cosmos itself? Let's explore that next. As we venture into the cosmos in search of resources, it's crucial to consider the environmental impact of our actions. Space, after all, isn't just a vast empty void. It's a delicate ecosystem of celestial bodies, each with its own unique characteristics. Mining asteroids, moons, and planets could disrupt this balance, creating unintended consequences that ripple across the solar system. One major concern is space debris. Every piece of equipment, every discarded fragment, adds to the growing cloud of orbital clutter that threatens satellites, spacecraft, and even future missions. AI and robotics offer a solution by enabling precise, controlled operations that minimize waste. For example, autonomous systems can be programmed to recycle materials on site, reducing the need to dispose of excess debris. Another pressing issue is the preservation of celestial bodies themselves. Mining activities could alter the composition of asteroids or scar the surfaces of moons, potentially erasing valuable scientific data about the origins of our solar system. Here, too, AI plays a pivotal role. Advanced algorithms can analyze geological data to identify the most sustainable mining sites, ensuring that extraction efforts cause minimal disruption. Companies are also developing eco-friendly technologies like low-impact drills and solar-powered mining rigs that reduce the environmental footprint of space operations. For instance, the European Space Agency's Prospect project aims to extract water from the Moon using energy-efficient systems, paving the way for sustainable resource harvesting. Ultimately, the goal is to strike a balance harnessing the vast resources of space while preserving its pristine beauty and scientific value. But as we navigate this frontier, we must also grapple with the ethical questions that arise. Who owns the resources of space? How do we ensure that interstellar mining benefits all of humanity, not just a select few? These are the questions we'll explore next. Ethical considerations are at the heart of the interstellar mining conversation, raising questions that go far beyond technology and economics. Who owns the resources of space? This isn't just a philosophical debate. It's a practical challenge with real-world implications. Currently, international agreements like the Outer Space Treaty of 1967 state that no nation can claim sovereignty over celestial bodies. However, the treaty is vague when it comes to private companies mining and profiting from space resources. This legal gray area has sparked heated discussions about ownership rights and equitable distribution. Should the wealth of the cosmos belong to the nations or companies that extract it, or should it benefit humanity as a whole? There's also the risk of exploitation. Without clear regulations, powerful entities could monopolize space resources, leaving less developed nations behind. This isn't just about fairness, it's about ensuring that interstellar mining becomes a force for global progress rather than division. AI and robotics can play a pivotal role in addressing these ethical dilemmas. Transparent, data-driven systems can monitor mining operations, ensuring compliance with international standards and reducing the potential for abuse. Blockchain technology, for instance, could be used to create an auditable record of resource extraction and distribution, fostering accountability and trust. International cooperation is another key factor. Organizations like the United Nations are already working to establish frameworks for responsible space exploration, aiming to balance innovation with ethical considerations. As we move forward, it's clear that the future of interstellar mining isn't just about technological breakthroughs, it's about building a system that reflects our shared values and aspirations. Looking ahead, the future of interstellar mining is nothing short of extraordinary, with AI and robotics poised to unlock a new era of exploration and innovation. Picture vast mining operations on asteroids, where fleets of autonomous robots work in unison, extracting precious metals and rare minerals with surgical precision. The Moon and Mars, too, will become hubs of activity, with advanced systems harvesting water ice for life support and fuel, and processing regolith into building materials for habitats and infrastructure. These technologies aren't just about resource extraction, they're the foundation for long-term human habitation in space. Imagine lunar bases powered by solar energy, constructed from local materials and maintained by self-sustaining robotic systems. Or Mars colonies thriving on in-situ resource utilization, where every tool, every component is created on-site using mined materials and AI-driven 3D printers. This isn't just science fiction, it's a vision that's rapidly becoming achievable. Back on Earth, the impact could be just as profound. Access to space resources could drive down the cost of critical materials, fueling advancements in technology, energy, and medicine. Entire industries could emerge, from asteroid prospecting to space manufacturing, creating jobs and opportunities on a global scale. The potential is limitless, but none of this would be possible without the groundbreaking technologies driving this revolution. In the next section, we'll take a closer look at the cutting-edge innovations that are making interstellar mining a reality and how they're shaping the future of humanity. At the heart of interstellar mining's evolution are the groundbreaking technologies in AI and robotics, each pushing the boundaries of what's possible in space. One of the most exciting advancements is in AI algorithms, which are becoming increasingly sophisticated at analyzing complex data sets. These algorithms can now identify patterns in geological formations, predict the best mining sites, and even optimize resource extraction in real time. For instance, NASA autonomous exploration systems use AI to process data from rovers and satellites, enabling them to make split-second decisions without human input. On the hardware side, robotic systems are being designed to withstand the extreme conditions of space. Companies like Honeybee Robotics are developing drills that can penetrate the toughest asteroid surfaces, while others are creating robotic arms with unparalleled precision for delicate operations. Sensor technologies are also taking a giant leap forward. Advanced sensors allow robots to see and feel their environment, detecting changes in terrain, temperature, and material composition with incredible accuracy. One particularly fascinating innovation is swarm robotics, where multiple robots work together autonomously. Picture a fleet of small, AI-driven machines coordinating to map an asteroid, extract resources, and transport materials, all without human intervention. Projects like the European Space Agency's Hera mission are already testing these concepts, aiming to demonstrate how swarms can operate in deep space. Another game changer is AI-driven predictive maintenance, which uses machine learning to monitor equipment health and prevent failures before they happen. This not only extends the lifespan of mining tools, but also ensures mission reliability in environments where repairs are nearly impossible. These technologies aren't just theoretical, they're being tested and refined in real-world projects. For example, off-world mining robots are being developed for lunar operations, while planetary resources prototypes are designed for asteroid prospecting. Together, these innovations are laying the groundwork for a future where interstellar mining is not just feasible but routine. But the progress we've made so far wouldn't be possible without another critical element: international collaboration. From shared research to joint missions, the global effort to advance space mining is as much about cooperation as it is about technology. As we venture deeper into the cosmos, it's clear that interstellar mining isn't just a technological challenge. It's a global endeavor that requires unprecedented levels of international collaboration. No single country or organization has all the resources, expertise, or infrastructure needed to tackle the complexities of space exploration alone. Shared knowledge is at the core of this effort. When scientists, engineers, and policymakers from around the world come together, they bring diverse perspectives and skills that can solve problems more creatively and efficiently. Take the International Space Station, for example. This multinational project has demonstrated how collaboration can lead to groundbreaking discoveries, from advancements in life support systems to innovations in material science. Similarly, missions like the European Space Agency's Asteroid Impact Mission and NASA OSIRIS-REx have shown how pooling resources can achieve objectives that would be impossible for a single nation to accomplish. AI and robotics play a crucial role in facilitating these partnerships. By standardizing technologies and processes, these systems ensure that equipment and data from different countries can seamlessly integrate. Imagine a mining robot developed in Japan working alongside a drilling system from Germany, all coordinated by AI algorithms created in the United States. This level of interoperability not only enhances efficiency but also fosters trust among international partners. But collaboration isn't just about technology, it's also about shared goals and values. As we move forward, it's essential that we work together to ensure that the benefits of interstellar mining are distributed equitably and that our actions in space reflect our aspirations as a global community. This brings us to the next critical piece of the puzzle: the regulatory frameworks that will govern space mining and ensure it's done responsibly and sustainably. The legal landscape of space mining is as vast and uncharted as the cosmos itself, presenting a unique set of challenges that demand innovative solutions. At the heart of this issue is the Outer Space Treaty of 1967, a foundational document that governs activities beyond Earth. While this treaty prohibits nations from claiming sovereignty over celestial bodies, it doesn't explicitly address the extraction and ownership of space resources by private entities. This ambiguity has sparked a heated debate about who has the right to mine asteroids, moons, and planets, and how those resources should be used. In recent years, some countries have taken steps to clarify these gray areas. For example, the United States passed the Commercial Space Launch Competitiveness Act in 2015, granting American companies the right to own and sell resources extracted from space. Luxembourg followed suit with similar legislation, positioning itself as a hub for space mining ventures. However, these national laws raise questions about consistency and fairness on a global scale. Without an international framework, there's a risk of conflicting regulations and potential disputes over resource claims. This is where the need for updated treaties becomes critical. New regulations must address not only ownership but also environmental protection and sustainability. After all, space isn't just a resource, it's a shared heritage that belongs to all of humanity. AI and robotics can play a pivotal role in ensuring compliance with these frameworks. Autonomous systems can monitor mining activities, track resource usage, and even enforce environmental safeguards, creating a transparent and accountable process. As we navigate this legal frontier, one thing is clear: the involvement of private companies will be a driving force in shaping the future of interstellar mining. Their innovation and investment are accelerating progress, but they also bring new challenges that must be carefully managed. This leads us to the next chapter in our exploration: the role of private enterprises in this groundbreaking industry. The rise of private space companies has been a game changer for interstellar mining, injecting new energy and resources into an industry once dominated by government agencies. Companies like SpaceX, Blue Origin, and Planetary Resources are leading the charge, bringing cutting-edge technologies and bold visions to the table. What sets these enterprises apart is their ability to operate with agility and innovation, unencumbered by the bureaucratic processes that can slow down government initiatives. This entrepreneurial spirit has allowed them to tackle challenges in ways that were previously unimaginable. Take SpaceX, for instance. While its primary focus has been on reducing the cost of space travel, its advancements in reusable rocket technology have directly benefited space mining efforts. Cheaper launches mean more affordable access to asteroids and other celestial bodies, making mining operations economically viable. Similarly, Blue Origin's focus on lunar exploration is paving the way for resource extraction on the Moon, particularly water ice, which could be used for life support and fuel. Planetary Resources, one of the first companies dedicated to asteroid mining, has developed sophisticated prospecting technologies, including AI-driven systems that analyze asteroid composition from afar. These private-led projects are not just pushing technological boundaries, they're also attracting significant investment. Venture capital and private funding are pouring into the sector, accelerating progress and fostering competition. This influx of resources is driving rapid advancements, from robotic mining systems to in-situ resource utilization techniques. The private sector's involvement has another critical advantage: its focus on commercialization. By treating space as a marketplace, these companies are creating sustainable business models that could make interstellar mining a long-term industry rather than a one-off scientific endeavor. But while the contributions of private enterprises are undeniably transformative, they're not without challenges. From technical hurdles to regulatory complexities, these companies face a host of obstacles that could shape the future of space mining. As we explore these challenges in the next section, it's clear that the road ahead is as exciting as it is unpredictable. While private companies are driving innovation in interstellar mining, their journey is far from smooth sailing. One of the most significant hurdles is the sheer cost of space exploration. Developing advanced technologies, launching missions, and maintaining operations in the harsh environment of space requires substantial financial investment. Even with breakthroughs like reusable rockets, the price tag remains daunting. For startups and smaller firms, securing funding is a constant challenge, especially when investors demand quick returns on risky ventures. This pressure to deliver results can lead to rushed decisions or shortcuts, increasing the likelihood of mission failures. Technological risks add another layer of complexity. Space is an unforgiving environment where even minor errors can have catastrophic consequences. Equipment failures, communication delays, and unpredictable conditions are just a few of the challenges that can derail a mining operation. Regulatory uncertainties further complicate matters. While some countries have established laws governing space resources, the lack of a unified international framework creates legal gray areas that can deter investment and delay progress. AI and robotics are proving to be invaluable tools in addressing these obstacles. From autonomous systems that reduce operational costs to predictive algorithms that minimize risks, these technologies are helping companies navigate the complexities of space mining. For example, AI-driven simulations allow engineers to test equipment in virtual environments, identifying potential issues before they arise in real-world missions. Robotics, on the other hand, enable precise, repetitive tasks with minimal human oversight, lowering the chances of errors. Despite these advancements, the road ahead remains challenging. That's where government agencies come in. With their resources, expertise, and ability to foster international collaboration, they play a crucial role in supporting private companies and advancing the field of interstellar mining. The role of government agencies in the development of interstellar mining cannot be overstated. Organizations like NASA, the European Space Agency, and others have been instrumental in laying the groundwork for this revolutionary industry. Through decades of research, funding, and infrastructure development, these agencies have turned ambitious ideas into tangible realities. Take NASA, for example, which has been at the forefront of space exploration since the 1960s. Missions like the OSIRIS-REx mission, which successfully collected samples from an asteroid, have provided invaluable data about the composition and potential of these celestial bodies. Similarly, the European Space Agency's Hera mission aims to test technologies for asteroid deflection and mining, showcasing how government-led initiatives are pushing the boundaries of what's possible. Funding is another critical contribution. Government agencies often provide the financial backbone for high-risk projects that private companies might shy away from. This support not only accelerates technological advancements but also de-risks the sector, making it more attractive for private investment. Infrastructure is equally important. From launching facilities to deep space communication networks, governments have built the essential systems that enable space exploration. NASA's Deep Space Network, for instance, allows for seamless communication with missions millions of miles away, a crucial component for any interstellar mining operation. Collaboration between governments and private companies is where the real magic happens. Public-private partnerships combine the resources and expertise of government agencies with the agility and innovation of private enterprises. For example, NASA, a commercial lunar payload services program, works with private companies to deliver payloads to the Moon, fostering a new era of lunar exploration and resource utilization. This synergy is accelerating progress, bringing us closer to a future where space mining is routine. But as we unlock the potential of the cosmos, it's important to consider the broader implications. How will this new industry shape society, from economics to culture? That's a question we'll explore next as we delve into the potential societal impacts of interstellar mining. The societal impacts of interstellar mining extend far beyond the realm of space exploration, promising to reshape our world in profound and unexpected ways. Economically, the influx of rare resources from space could fuel industries back on Earth, driving innovation and reducing the costs of critical materials like platinum, gold, and rare earth elements. These elements are essential for everything from smartphones to renewable energy technologies, and their increased availability could accelerate the transition to a greener, more sustainable future. But the benefits don't stop there. The technologies developed for space mining, AI, robotics, and advanced materials are already finding applications in other sectors. For example, autonomous drilling systems designed for asteroids are being adapted for deep-sea exploration on Earth, opening up new frontiers in resource discovery. Education is another area poised for transformation. The excitement surrounding space mining has the potential to inspire a new generation of scientists, engineers, and explorers. Programs like NASA, Artemis missions, and private initiatives by companies like SpaceX are already capturing the public's imagination, encouraging students to pursue careers in STEM fields. This wave of interest could lead to breakthroughs in science and technology that we can't yet even imagine. However, as we unlock the treasures of the cosmos, it's essential to address the challenges of equitable resource distribution. The wealth generated by space mining must benefit all of humanity, not just a select few. This requires international cooperation and thoughtful policy making to ensure that the resources of space are used responsibly and fairly. The ethical responsibility of those involved in space mining cannot be overstated. We must consider the long-term consequences of our actions, from environmental preservation to the potential for exploitation. As we venture into this new frontier, it's crucial that we do so with a commitment to fairness, sustainability, and the betterment of humanity. This leads us to the next critical question. How can we ensure that space mining aligns with our shared values and aspirations as a global community? As we unlock the vast resources of space, a critical question arises. How do we ensure that interstellar mining is conducted ethically and responsibly? The moral obligations of governments, companies, and individuals involved in this industry are immense, requiring a commitment to principles like sustainability, fairness, and transparency. Sustainability is at the forefront of these responsibilities. Mining celestial bodies could have lasting environmental impacts, from altering the composition of asteroids to contributing to space debris. It's essential that we minimize these effects, treating space as a shared heritage rather than a free-for-all resource. AI and robotics are powerful tools in promoting ethical practices. AI-driven systems, for instance, can monitor environmental impacts in real time, ensuring that operations remain within sustainable limits. Robotics, on the other hand, enable precise, low-impact extraction methods that reduce waste and disruption. Fairness is another key consideration. The wealth generated by space mining must benefit all of humanity, not just a few privileged nations or corporations. International cooperation and equitable policies are crucial to achieving this goal, ensuring that the resources of space are distributed justly. Transparency is equally important. Open data sharing and accountability frameworks can help build trust among stakeholders, fostering a collaborative approach to space exploration. Organizations like the United Nations Office for Outer Space Affairs are already working to establish guidelines for responsible space activities, while private companies are adopting ethical practices voluntarily. For example, Planetary Resources has committed to sharing data from its asteroid prospecting missions with the scientific community, contributing to our collective understanding of space. These initiatives are steps in the right direction, but the journey toward ethical interstellar mining is far from complete. As we move forward, it's essential that we remain vigilant, ensuring that our actions in space reflect our values as a global community. This brings us to the final piece of the puzzle, the long-term vision for space mining, a future where innovation and ethics go hand in hand. The long-term vision for interstellar mining is nothing short of awe-inspiring, offering a glimpse into a future where humanity's reach extends far beyond Earth. Picture a scenario where colonies on the Moon and Mars are thriving, sustained by the resources harvested from nearby celestial bodies. Water ice mined from lunar poles could provide drinking water and oxygen for astronauts, while hydrogen extracted from asteroids could fuel rockets, enabling deeper exploration into the cosmos. These resources aren't just stepping stones, they're the foundation for a new era of interplanetary colonization, but the potential doesn't stop there. As we venture further into the solar system, space mining could unlock the resources needed to explore and even settle distant worlds. Imagine mining stations on the moons of Jupiter or Saturn, providing the materials to build habitats, spacecraft, and infrastructure. These outposts could serve as launching pads for missions to the farthest reaches of the galaxy, turning science fiction into reality. At the heart of this vision are AI and robotics, the unsung heroes making these ambitious goals achievable. Autonomous systems allow us to operate in environments where humans cannot, from the harsh vacuum of space to the unpredictable surfaces of distant asteroids. Machine learning enables us to process vast amounts of data, identifying resource-rich sites and optimizing extraction methods. Robotics, on the other hand, provides the precision and versatility needed to perform complex tasks in zero gravity. Together, these technologies are transforming the way we think about space exploration, turning it into a sustainable, scalable endeavor. Beyond the practical benefits, interstellar mining has the potential to redefine humanity's place in the universe. By tapping into the resources of space, we're not just expanding our horizons, we're securing our future. This isn't just about survival, it's about thriving, about becoming a multiplanetary species capable of exploring the stars. As we stand on the brink of this new frontier, one thing is clear: the possibilities are as limitless as the cosmos itself. Throughout this journey, we've explored how artificial intelligence and robotics are revolutionizing interstellar mining, transforming what was once the stuff of science fiction into a tangible reality. From autonomous rovers navigating alien terrains to AI systems analyzing asteroid composition, these technologies are tackling the immense challenges of space's harsh environments, vast distances, and unpredictable conditions. We've examined the groundbreaking innovations driving this field, from self-repairing robotic systems to AI-driven resource mapping, and how they're making space mining efficient, sustainable, and scalable. The collaborative efforts of governments and private companies are accelerating progress, while ethical considerations remind us of the responsibility we hold to preserve the cosmos for future generations. The economic potential is staggering, with space resources poised to fuel industries on Earth and beyond. But perhaps most exciting is the long-term vision, a future where humanity thrives as a multiplanetary species sustained by the resources of space. This isn't just about mining, it's about building a new era of exploration, innovation, and possibility. The road ahead is filled with challenges, but with AI and robotics as our tools, the stars are within reach. So, what's next for you? Stay curious, stay informed, and join the conversation about the future of space exploration. The cosmos is calling, and together we can shape a future that's out of this world.